Yeah, so I went about this kind of a different way where I'm not super technical. I've run companies in the AI space. I'm not an engineer. So I went about this a totally different way. Um, what's the problem here? Um, data sets. What if you're working in a domain where there's no open source data set for it? So we're currently right now, we do work in a space where there just isn't open source data sets available. And that was my problem as a non-technical person, which is why I took this course, by the way, to become more technical. Um, how do you create a data set to train a model on? And so that's what I tried to solve with this. Or the issue of data sets, maybe it's not large enough. So then we'll go through fine tuning as a solution. I'll give you a demo and show you the results of what I was able to do. So there's limitations with off-the-shelf models, right? With their knowledge base being generic. It's broad approach. They cover a wide range of topics, but they don't cater to your specific niche, right? And there's ways to solve this right now with RAG, but I think what we did is a great implementation for RAG later on. Um, so you can personalize LLMs and make them more relevant for specific applications, but it requires a data set, right? This is what I was talking about, where what if you don't have a data set? And particularly in a data set in question and answer format to train the models on your specific knowledge and interaction desired. Whoops. So not everyone has access to these pre-formatted Q&A data sets that align with their specific needs, making it hard to really train a model for your specific need. So what's the solution? Well, make your own. Take a document, basically a PDF, a text doc, a document, or a CSV file, convert it into a data set, and then train a model based on it. So what we did is went out and found this basically a generic PDF on cars. What do you do with cars? What are cars? How do you fix them? We took that and we put it into a workflow where the user, they simply upload the document that they have. And it can be, like I said, a PDF document. It could be multiple documents, a knowledge base on your company, stuff like that. Takes it into a data set generation pipeline where it creates a data set from those documents, then takes it to a fine-tuning a model. For this, we use Mistral. We plan to use a small language model on it, but for personal reasons, ran out of time. And then you have the ability to chat with that personalized model. Again, this goes through providing the raw text, converts the text into a data set, normalizes that data set. Then we integrated also having the option of creating synthetic data from that data set. So creating additional data if your data set's not big enough. Maybe you want a larger data set that you just don't have. So then it normalizes that data set again, sends it to the supervised fine tuning, fine tunes the model, and then I'll show you the metric score that we were able to achieve. So basically, this is kind of a walkthrough of how it works. We just did it on Streamlit real quick. So you upload the document. You can select the number of QA pairs. Right now, it's limited to 100 just because of Streamlit limitations. This pings to right now it goes to our AWS implementation to generate QA pairs. And then let me fast forward here a little bit. It takes a little while. There we go. So it's done with that. You can download the QA pairs, take a look at it. We'll show the CSV of these. It comes out in this format, right? You take that. Okay, now I want to create a synthetic data set for it. We have the limit on this set at 1,000, but just for this quick demonstration, we did 5. So it's generating that. And you'll see here that it is going to, okay, created that synthetic data set, put it as a CSV. And you'll see now there should be more questions. Yep, so there's more questions here. This is the original one, and the new one has some more questions to it. So then what do? Train the model, right? So this is like me as a non-technical person, this is what I wanted, right? Take something simple and train a model with it. I don't want to have to code. I don't want to have to program every time or run it in a Colab notebook that I didn't know how to do before, you know? So yeah, so it does that. And then basically the next step is, okay, here's your model. You select your model that you've chosen. Here's a sample question, right? Taken from that. Goes through, spits out an answer. Oh, where we go here? Here we go. Fast forward a little bit. There's the answer. Go back to the data set. You can compare it. It's pretty good. We did another example here. What should I check when filling up my car? And this is all information that's domain specific. So it's meant to be very domain specific. And there you go. Check the fluid levels. All that, great. Which is, there you go. Check the fluid levels. So how do we measure the performance of this? Basically with semantic similarity. And measuring the model's performance, we used an average semantic similarity with the training data set. And this is how we did it. And basically the base was about 50%, and on average, it turned out to be the base was 50% and the fine-tuned on average was about 89%, which came out pretty good, I thought. So a big increase in accuracy, which was really good. And here's an example. So what turns the crankshaft? This is the base model example, the base model response, and then the fine-tuned response. You can see it's much more detailed, clear, and comprehensive, which I think came out really well. Here's another response. Again, much more comprehensive, and it really explains the contrast for the question very specifically. So what can be improved? What's next for this? Better QA dataset generation. Include more file formats, maybe JSON file uploads. Increase the size of the dataset generation. Obviously, an improved UI. Implement it with small language models, accuracy improvements, and eventually what we plan to do is create a fine-tuned dataset generating language model, because right now it's pinging through our AWS server to Claude to convert that text into data sets. But we plan to fine-tune a language model specifically for that, and then eventually to deploy it, open source it, so that people like me who want to create a language model to use can do it. And yeah, I think the future of this is really great for an implementation into a RAG application as well, for really accurate answers. And that's it.